Hey guys, we're on day 4 of Unit 7, and we're going to talk about recursive formulas. So recursive formulas are different than explicit. Explicit are nice and user-friendly. If you want to find the 100th term, you plug in 100. But recursive, if you want to find the 100th term, you got to plug in whatever the previous term was, which is the 99th term. So you got to figure out what that is and then plug it in. All right, so it's a little bit on the trickier side. In recursive formulas, they have to tell you your first term so you can find the next term, which is the second term, okay? And in their formulas, you're going to see a little bit of different notation. That's a sub n minus 1. N minus 1 is the subscript, so they pronounce it a sub n minus 1. All right, and what that is the previous term, okay? And that's something you're going to have to get used to so you understand how these formulas work, okay? If you look, come down here and look, whatever our term is, okay, a sub n, if you want to get to the term, let's say it's the 10th term, okay? We know that the next term would be the 11th term, and then the following one would be the 12th term. So you have to realize what they're doing to their subscript. So they're taking the subscript of n, and to go to the next one, they're adding 1, okay? This would be n plus 2. You're adding 2 from our starting point here to get to the 12th term, all right? If you want to go backwards in the sequence, obviously this would be the 9th term, and so you would say a sub n minus 1 to go backwards, okay? This would be the 8th term, which would be a sub n minus 2 to go backwards 2 terms, okay? So you got to watch out for the notation that they're using, all right? Notice here, a sub n minus 1 would be the previous term to a sub n. Okay, it's the one before it. Here, a sub n would be the previous term to a sub n plus 1. Okay, and so they can be a little tricky, all right? So these ones have R's, so that's a common ratio for our geometric sequences, and these ones have D's. But notice that's the only difference between these, okay? This is still the previous term, the one before it, okay? So they could use that notation. They could also use this notation, all right, where a sub n is the previous term to that, okay? A sub n minus 1 is the previous term to a sub n, okay? So how do we find terms? Since the first term is given to us, we're going to go ahead and plug it in to find our previous term, okay? We have to remember to substitute our previous term anytime we see this notation of a sub n minus 1. And hopefully they stick with that notation. But again, they could use a sub n and a sub n plus 1, okay, for your notation here. All right, and then you may just keep repeating the process. It's not bad once you get the hang of recursive sequences, okay? So let's see our first 3. Okay? They want us to generate the next 4 terms for the following sequences. And so here we go. So cool thing is first term's given that to us, but they want the next 4, so we still have to generate 4, all right? And so we'll go ahead and find a sub 2. Okay? What this formula is saying, I'll give you the lowdown on it, but that n becomes 2, so that n would become 2, and 2 minus 1 for the subscript becomes a sub 1, and a sub 1 is right here, okay, which is 2. And so that goes in for this, and then plus 6. And our second term comes out to be 8. Okay, so I'll show you one more time, a sub 3. If that subscript becomes a 3 now, 3 would go there, and 3 minus 1 would now be a subscript of 2. And a sub 2 is what we found here, which is 8. And so 8 goes in, plus 6. And so our third term comes out to be 14. Okay, so you see what happens? Okay. Again, I could go ahead and change that subscript to a 4 now, but this one would change to a 4, and then the subscript would say 4 minus 1, and so now the subscript would become 3, and a sub 3 is my third term, which we just found is 14, and so 14 goes in, and then plus 6. Okay, so it's just a repetitive pattern. All right, 14 plus 6 is 20. All right, they said next 4 terms, so I got to keep going. A sub 5. So again, as soon as you realize that this a sub n minus 1, okay, means previous term, you just go grab the previous term that you just generated, which this time is 20, and add 6. And there is my 5th term, which is 26. And there's the next 4 terms in my sequence. Okay, all right, so let's try again. All right, so again, the first term is given to us, so we're going to find the second term. So Okay, so the second term, okay, 3 times, remember this is our previous term notation, okay? And since we're finding the second term, our previous term is 9. So 9 goes in, minus n, and remember n, okay, is our subscript, which is 2. And so we put 2 in, and out comes our second term. 9 minus 2 is 7. 7 times 3 is 21. And now we're going to go find the third term. Okay, formula says 3 in parentheses. Again, that's our previous term notation. Our previous term is the second term, which is 21. Okay, minus n. Remember, n is our subscript, which is 3. Okay, so just make sure that you plug in the right thing in the right spot. Okay, 21 minus 3 is 18. 3 times 18 is 54. All right, so now we'll find a f sub 4. Formula says 3, parenthesis, previous term comes out. Previous term to the fourth term is the third term, which is 54. Minus n. N is our subscript, which is 4. Okay, 54 minus 4 is 50 times 3 makes 150 for our fourth term. And now we're finding our fifth term. So 3 stays, parenthesis. Okay, previous term notation would make our previous term of 150 minus n, which is our subscript, which is 5. Okay, so we get 145 times 3, and our fifth term is 435. All right, so next one, a little bit different, a little bit scary. They gave us not only our first term, but also our second term. All right, so that means we want to find our third term, so t sub 3. But notice the notation here. All right, so in the middle one, we didn't have to, pay too much attention to it, but look at all these subscripts. So what we have to remember is that this is the term we're finding, t sub n. Okay, so t sub 3. All right, this would be the previous term to it. Okay, this would be the term after it. So we got to be careful here. All right, so remember that it goes t sub n. Okay. After it would be t sub n plus 1. And before it is t sub n minus 1. Okay. So this term is the 5. This term here is the 8. Okay. So a tad on the tricky side for sure. Okay. So here we go. So formula says 3. Okay. This is going to become my 8. Okay. Minus t sub n minus 1 is my 5. Okay. So we get our third term being 3 times 8, 24, minus 5, 19. Okay, so now this becomes t sub 4, okay, 3. All right, so now we have to go ahead and this might be easier too. If you actually take the n in your subscript, so let's clear this out just to show you another way that you can think of it. Okay. Notice we want t sub 4 here. Okay. So in order for this to be a t sub 4, this n has to be a 3. This n has to be a 3, and this n has to be a 3, and that subscript of 3 minus 1 becomes a 2. Okay. And so this is now 3 times my t sub 3, which I just found is 19, minus my t sub 2. My t sub 2 is 8 that was given to me. Okay. So 3 times 19 minus 8 gives us a t sub 4, or a fourth term, of 49. All right, t sub 5. So now remember, in order to make this a 5, we have to make this a 4. So that 4 plus 1 is our subscript of 5, okay? Which then means this becomes a 4, okay? And this becomes a 4 minus 1, which is a 3. All right, so now we can plug in, and that might be a little bit easier for you. Okay, so this is a 3. T sub 4 is the one I just found, which is 49, minus t sub 3, which is one before that, which is 19. Okay. And so my fifth term comes out to be 3 times 49 minus 19. Okay, it's 128. And now we'll go ahead and find t sub 6. Okay, so that's 3 times. And you might be starting to notice the pattern, or you can keep plugging in, okay? So this would have to be a 5 for your n, so that when you add 1, that gives you that subscript of 6, which is what we're on. Okay? This would therefore become a 5, and this would become a 5 minus 1, which is 4. Okay? And so this is going to be a 3 times my t sub 5, which I just found, which is 128, minus my t sub 4, which is the one before that, which is 49. And so my t sub 6 comes out to equal 335. And those are done. Okay. All right, let's take a look at what we have next. It says determine a recursive formula in terms of a sub n for the sequences shown below. So what they now want to do is go backwards. Instead of giving me the sequence and generating the terms, they generated the terms, but we have no formula for our sequence. Okay. Since they want us to write a recursive one, we have to remember what they gave us up above in number 1. The very first thing that they stated was the first term. So we'll say a sub 1 equals 5. That's very easy. Okay? Next, we're going to need a formula that has the previous term notation in it. Okay? So we have to know, what are we doing to the previous term to get our term? Okay? What are we doing to 5 to get 10? Right? And there's 2 things we could do, right? We could add 5, or we can multiply by 2. All right, so now we have to go ahead and see what's going on. But if you notice, 10 to 20 is multiplying by 2. So what we're doing is we're doing 2 times the previous term. So 2 times, and previous term notation is a sub n minus 1. Okay, the whole n minus 1 has to be the subscript. Okay, so that's how we're going to do that. So if 5 goes in, 2 times 5 is 10. Then 10 would go in for the previous term, and 2 times 10 is 20. Okay, then 20 goes into the previous term spot. Okay, 2 times 20 is 40, and so on. All right, and so there is our formula. Okay. All right, part B. First term has to be given for recursive. So we'll say a sub 1 equals 18. Now we need a formula that has a sub n minus 1 in it, which is the previous term. So we have to know, what are we doing to the previous term, okay, to get 15. All right. And the first thing I see is adding a negative 3, right? Or you could say subtracting 3 in this one. 15 take away 3 is 12. 12 take away 3 is 9. All right. So we're taking our previous term, which is a sub n minus 1, and we are subtracting 3 from it. Okay. A lot of people will put this in parentheses. Okay. You don't have to in this case, but sometimes it helps. All right. Last one here. So we'll say a sub 1 equals 6. Okay. And then we'll say a sub n equals, what are we doing to the previous term? So we could be adding 3, or we could be multiplying by 1.5. And since there's decimals here, I'm thinking 9 times 1.5 is going to go ahead and give us 13.5. 13.5 times 1.5, okay, will give us 20.25. So we're taking 1.5, or 3 halves, okay, and timesing it by our previous term. Okay. And there's our formulas. Okay. So hopefully you guys can go both ways. Okay. Like in number 1 and number 2. All right. I'll see you guys on the back side of note.